Hey guys, it's Miss Pear. So, I was going to go ahead and, sorry I can't be with you guys today. As I mentioned in the packet, I am out for a wedding, but we needed to keep going since we lost some time because of the hurricane. So, this is for after you have finished the quiz. Now, please don't freak out. It might not be counted as a quiz. Right now, just think of it as a quick check to see where you are. And we'll take it from there. Okay? All right, so we're going to take a look at the first page, page 1 here. What I want you to do is just pause the video, and I want you to go ahead and write down as many observations as you can based on this graph. Think about the numbers, think about what they mean, and things like that. So go ahead and pause the video, and when you're ready, come back. All right. So here's some things that we can take a look at. We want to take a look at the title, number of hot dogs and burgers you can buy for $30 or less. We want to pay attention to our X and our Y axes. So this is representing the number of burgers I can buy, and this represents the number of hot dogs. So one thing that we can see right here is that we've got 2 points. At this point, what does this point tell me? Well, I bought 0. If we take a look at that point is 0.35. Well, the burgers are my X axes, right? And my hot dogs are my Y. So how do I interpret that? If I buy 0 hamburgers, I can buy 35 hot dogs. And then the opposite is true here. We can take a look at this point, and this point is 20. So I can interpret what that coordinate means in this situation. If I buy 20 burgers, I won't buy any hot dogs. So that's how I can interpret these 2 points. These 2 points, this right here, is called our x-intercept. And we talked about that in the beginning when we first started with our graphing. Whenever the line crosses the x-axis, that's the x-intercept. And this is our y-intercept. Okay, so our x-intercept is when y is 0, and our y-intercept is when x is 0. Okay, so the y-intercept is where it crosses the y value. That's why we have a y value. All right, so we can interpret different points and what they mean at that time. We can also take a look at our slope. All right, our slope is going down. All right, it means not that I'm buying negative hot dogs, but it means as my hot dogs decrease, my burgers are increasing. So hot dogs, as my hot dogs decrease are negative, my hamburgers are increasing. So that's how we're going to take a look at some of these graphs today to kind of tell us how we can read and interpret different graphs, and especially for real life situations. So we can look at their intercepts, and we can also take a look at their slope. And then any coordinate on the line will also be able to tell us different values. So for example, here, now this isn't a nice clean point, but I can estimate that if I buy 10 burgers, it looks like I can buy about 17 hot dogs. So if I want to spend $30 or less. So that's what that kind of gives us. So let's go down and take a look at these 3 graphs down below. Now these 3 graphs, all we're going to do is we're going to take an observation. M stands for slope. Now again, weird letters. B stands for y-intercept. Again, don't ask me why. They decided to just throw out weird letters there. And x-intercept doesn't have a special name. It's just x-intercept. No weird letter like the letter, I don't know, what would be a weird one? J. J would be a weird one for x-intercept. So all I want you to do is we're going to first take a look at graph A. We're going to find the slope, the y-intercept, and the x-intercept. All right, well, the slope, again, find 2 points, 2 nice clear intersections, and I can see right here those 2 points. So I go up 1 over 1. So my slope is 1. Makes sense? It's positive. My y-intercept is right here, where it's crossing the y axis, so that's 1, 2, 3. Now I'm assuming that we're counting by ones because it's not labeled, so it's okay to assume that here. So my x-intercept is 3. We can just, y-intercept. All right, we can write it as just 3, and that's just to also be aware that that means 0, 3. Okay? The y-intercept, by definition, means that our x is 0, but we also want to be able to recognize this way. All right, and our x-intercept is right here, where it crosses the x-axis, and that's 1, 2, 3. That is at -3. Again, if you had to write it as a coordinate, it would be -3, 0. All right, what I'd like you to do right now is go ahead and pause the video and try graph B and C. Then unpause the video to check your answers. All right, check to see how you did. Now, graph B was a little bit hard to find those nice clean points. I really didn't find them except at the origin and at the very 2 arrow tips. Everything else was not across a line. So I found these 3 points and I highlighted them, and that's how I found my slope. So I went down 5 and to the right 3. And I double checked it by finding another one, down 5 and to the right 3. So -5/3. My x and my y-intercept happen to be the same value. It's the origin, 0, 0. Over in graph C, my slope is undefined. You cannot write 0. Okay, 0, remember, is 0 fun. It's a flat line. Now, y-intercept, there's nothing that I could write. It's not that it's undefined, it's just that there isn't one. So you can write NA, like not applicable. There isn't one. Okay, it doesn't cross the y-axis. So it's okay. Sometimes we're not going to have a y-intercept. Just like if we had a 0 slope, we might not have an x-intercept. Okay? In this case, my x-intercept is right here, and that's at 3, 0. So my x-intercept is 3. All right, so that's just looking for the slope, the y-intercept, and the x-intercept on a graph. Now let's see it, how we can interpret that. All right. Okay, so now we see that we have a whole bunch of different line segments. Okay? We have segment A, B, C, D, E, and F. Okay? And we're going to take a look at how we can interpret each of those line segments and what they mean. So if we read this here, it's a distance time graph for Mark's 3.5-mile cycle ride to school. So we can see that on our x-axis we have time in minutes and the distance he rode in miles. So during this ride, he rode on cycle paths, but the terrain was hilly. He rode slower up hills and faster down them. He stopped once at a traffic light, and at one point he stopped to mend a punctured tire. The graph shows his distance from home at any given point. At any time. Identify each section of the graph accordingly. So we're going to try and match up what his situation is with what his graph shows. Okay? So first off, it says that it was hilly. He rode slower up hills and faster down them. So let's try and first find the slope of each line segment. So for A, we have he went from 0 to 4, about 4 minutes, roughly. Okay, so from 0 to 4, so he went 4 minutes. That's our x. And in our y was a half a mile. So that's his slope right there. That's a half a mile in 4 minutes. And then we see here from, we could even argue, I guess, that that's more like 5. Maybe we should do that. So about 5 minutes. So a half a mile in about 5 minutes. So then from here, 5 to about, looks like 7. So for 2 minutes, he was stopped. Okay, because he's still at that half, there was no change in his y value. So there's no change after 2 minutes. So that is a slope of 0. Okay? Then from 7 to 14 minutes. So that's 7 minutes. That's in our x-axis. He went from a half a mile to about, we'll estimate it about 1 mile. So that was another half mile. So he did a half a mile in 7 minutes. That's a lot faster than A. Then we see that we have a really steep line here. From 14 to, let's see, what is it, 20? 14 to 20. So that's 6 minutes went by. And we said about 1 mile, 3 miles, so that's a change of 2 miles. and I should be writing this. This is minutes, miles. Miles, minutes, miles, minutes. Okay? And then E, from 20 to about 25, so that was 5 minutes. He hasn't gone anywhere, so we have another slope of 0. So 0 miles in 5 minutes. And then from about 25 to 30, so again another 5 minutes, he went a half a mile. All right, so we have taken a look at the slope. Now we're going to compare it. So where was he going uphill? Where was he going downhill? Where did he stop at the traffic light? And where did he mend the punctured tire? Okay, so where's he going the fastest? Okay, 2 miles. So if we were to estimate this and round this to make sense for ourselves, okay, this is let's make it all, this is 1 mile in about 10 minutes. This is 1 mile in 14 minutes. This is 1 mile in 3 minutes. And this is 1 mile in 10 minutes. Okay, so by just looking at the slope, we can get some comparisons here. So he's going 1 mile in 14 minutes in section C. So that sounds like he's probably going uphill here. It's going kind of slow. 1 mile in 10 minutes, that's still a little bit slow. It sounds like he's struggling, so that might not be a hill, but maybe not as steep as section C. Okay? And then 1 mile in 3 minutes, that must be one steep hill that he is going down. So he's going downhill here. Now, here he stopped for 2 minutes, here he stopped for 5 minutes. So he stopped at a traffic light, and that he also had a punctured tire. I'm going to go with this is where he had to mend his punctured tire, because I think that's going to take a little bit longer than waiting for a traffic light. So by looking at that graph and matching it with the story, we've kind of come up with, by just looking at the graph, we were able to kind of match what's happening with Mark's ride. Go ahead and pause the video at this time and see if you can interpret graph number 2, just like we did up above. Alright, let's see how you did. Okay, we can see here that in section A and section C, I found their slope and I went ahead and simplified them. And I can see that he was going 40 miles per hour in both A and C. So that's when he was driving to his deliveries. Now, it said that he made 2 deliveries, one taking an hour and the other taking 2. Well, here I can see that he stopped because he didn't go. He stopped for an hour and he stopped for another 2 hours. So here's where he made his 2 deliveries, were B and D. Now, the interesting thing about E is that sometimes people go like, oh, he must be going downhill. Remember, this is the distance he is from where he started. So he's driving away to his first delivery. He drives further to his next delivery. So at this point, he is 120 miles away from his starting point. So now he is returning home. So this x-intercept right here tells us that his total day took him 8 hours. So in this last set, I can see that in section E, he drove at a speed of 60 miles per hour to get home. So he was able to go a little bit faster than when he was on his way there. So his whole trip took him a total of 8 hours. However, his return trip only took him 2 hours, 120 miles in 2 hours. So that is how we can read and interpret graphs. All right? What you're going to do is take what you've learned about x and y intercepts and slope and how to interpret them by paying attention to the x and y axis labels and the title, and see how you can go ahead and answer these questions. All of them are multiple choice except for number 5, where you do have to write that one in. Okay? Don't forget that there is a back. Please try your best on this, and we'll go over them on Monday. All right, guys. Have a great rest of your day and a great weekend. I'll see you guys Monday.